Welcome. This is the Artificial Intelligence class, week 4, I believe. And today we're going to be talking a lot more about AI agents. So in the past couple of weeks, we've covered a bunch of different things. We've covered types of neural networks, artificial intelligence, how it works, exactly it is, where it's applied. But today we're going to be, and I kind of mentioned last class that we were going to be talking about AI agents because they're honestly just this really cool part of artificial intelligence that's really, really trending right now. It's really popular, and it's something all of y'all should know, and even better, get to work with because you can use them in so many different ways. Okay, all right. So just going straight into it, AI agents can basically be called digital workers. We have real workers, human workers who do a lot of different tasks, construction workers, people who chefs, employees in various different companies. Digital workers are basically software that can do similar things. Of course, today you'll be pretty hard pressed to find an AI agent that can build something for you, like that can do construction, but there are many AI agents that can build apps or do many different things. In fact, I've shown all of y'all, a sample AI agent, v0.dev, or at least something that has agent-like capabilities in the past. So basically, you could think of AI agents as workers, digital workers that can do whatever you want, and they can do it without requiring your help all the time. So you don't have to be sitting in front of your computer. You could go out for, a long walk, and this digital worker, the AI agent, can do your homework for you or whatever you want. Of course, don't use it on homework. But like if you're working on a project, a cool project, and maybe even Roblox games, because I know many of y'all are into Roblox. In in these cases, these
Especially Grow
digital
Garden.
yeah. So yeah, in these cases, these digital workers could probably help. So a few things to note about digital workers or AI agents. You have something called the schema, which is known as the initial rulebook. So just, in your head, relate these two words, schema, rulebook. You could see it as like a menu as well, a menu card or an instruction manual, something that helps the AI agent get working. So once you give the schema to the AI agent, it really doesn't require your help from that point on because the schema has all the instructions it would follow to get the work done. And I think we'll be going into AI agents a lot more, in the types of AI agents. And of course, if any of y'all have any questions at any point in time, unmute. You can interrupt me. That's all right. And yes, as I said before, using the schema, AI agents can continuously operate. Okay, that was a quick run through on AI agents. I don't expect y'all to, understand them completely because we have a lot of examples, but at least know that AI agents are basically digital workers. Okay, and here's the fun part I got. I tried my best to find some cool images that you could relate AI agents to. So AI agents are chatbots. So for all of y'all who use ChatGPT or Gemini or any other chatbot or chatting, AI system, it would be to some extent an example of AI agents. Digital twins can be considered AI agents. Self-driving cars, probably the coolest example on the list. And self-driving drones or self-navigating drones are also an example of AI agents. Then you have writers as well. There's many AI agents that can write things for you. They can write newspapers, they can write books, they can write stories. They can write many different things for you. And then you have AI agents that can also edit videos for you. Many different video editing softwares or video editing programs out there have AI agentic capabilities. And when you hear the word agentic, you could generally just think of it as something related to an AI agent. And finally, as I mentioned before, there are also AI agents out there that can help you develop games. Okay. And okay, I'm going to slow down a little bit more. I wanted to take y'all through a cool example of digital twins. So in the previous slide over here, I mentioned the word digital twin. So the other examples are a little bit more, intuitive understanding. Like if you just see these words, you could probably understand. But digital twins is probably the big one on the list. And it's honestly probably one of the coolest ones. So if y'all have watched Star Wars in the past, this is the Millennium Falcon. And and this is also a humanoid. But what a digital twin is, it's really a replica, a digital replica created by an AI system of a physical object or a physical person even. And it has like the same properties, or it like works in the same way as, a person. For example, through an AI agent system, you could create an AI agent of me, and it would talk like me. It would look like me for sure, but it would also, even act like me, or it would really look like me, or you'd be able to, you'd easily be mistaken, uh, for considering, for it being me, basically. In short, it's just a really good replica of a real person, a real object. Okay. And this is created by, AI systems, AI softwares, AI programs, pretty advanced AI programs. And this would be considered an AI agent because it can act autonomously. And there's so many different ways digital twins are applied. If any of y'all are interested in, building planes or spacecrafts, digital twins are used all the time there. Because, for example, if NASA wants to launch a specific rocket to, I don't know, Mars or somewhere else in the galaxy, a great way to test that rocket without wasting, materials, or wasting, or, harming people or whatever, or any animals, is to use digital twins, these AI agents that you could launch in a simulation, and it would be able to act just as the real rocket or spacecraft would act. And digital twins can be used everywhere. Like, for example, you can create a digital twin of your house as well and test it during an earthquake or whatever. And the AI agent, which is the digital twin, the replica of your house, would respond to that. So just note, digital twin is a really good replica of basically anything out there. And yes, also another thing about digital twins is that it can actually, you can kind of, let's say, talk to the digital twins, or it would be able to give you real-time data or feedback. For example, if you talk to your house, if you talk to the walls, right, they're most likely you won't hear anything back from the walls. But from a digital twin, you will, uh, get data from, from the replica or the digital twin. So because these are, at the end of the day, these are autonomous agents. Whether your real house walls are autonomous agents, that's a different thing. But these digital twins, they can give you real time data or feedback. Okay. So that's a cool tangent. Just know digital twins. It's really cool. Okay. Now here's something which some of y'all might have heard of, some of y'all might have not, an API. It's, in short, it stands for these three words over here, application programming interface. And you can just look at the definition, I'll read it out. These are rules or tools that allow software to talk and work with each other. So I have to say, when I first heard of this word, I was pretty lost and pretty confused as well. But here's a really good analogy I found from a YouTube video actually on AI agents. Maybe I can share it later if any of y'all are interested. It's a pretty cool video. In that video, the YouTuber describes an API, application programming interface, like a waiter. The waiter or the waitress, they go and ask for your order, and you're like the customer. So in this case, the customer is also like the user. All of us who are, talking to AI systems or even using our computer for that matter, we're like the customers, or yeah, the customers. And then the waiter is bringing the order to the chef. Now the chef can be seen as like the server, the digital servers, the computers, and they're actually like cooking the dish for you, or they're like creating the software or AI system. So the chef can also be seen as an AI system. And what an API is, it's bringing information, your request, from you to the chef, and it's also bringing your food or the chef's response back to you. So, for example, if you're using ChatGPT and you're asking ChatGPT to solve a math problem, you're placing the order for the math problem to be solved. And the API takes your order to the chef, the AI system, and that AI system solves your math problem for you. And it returns your dish or your solved math problem back to you through an API. So just note that APIs, application programming interfaces, are rules or tools allowing software to talk and work with each other, or in short, communicate with each other. The keyword is communicate. And it's kind of like a waiter. So if you ever have a little trouble understanding what an API is, just think of a waiter and what a waiter does when they take orders from you and bring you back your food. Okay, so there's four types of AI agents. I don't expect y'all to, understand it based on my explanation, because these are going to be coming in the booklet as well. And I'm sure y'all will at least understand this a lot more in the booklet. If y'all are taking notes, it'll definitely help you. Because this will probably be one of the more technical topics in this whole, in this whole summer camp. And also in this AI class, this is probably going to be the most technical side of it. So yeah, and I'll try my best to explain it in the easiest way possible. And at the same time, if y'all could ask me questions either in the chat or unmute. As I said before, y'all are free to interrupt me. So that I think that would really help everyone understand these topics a little better. Okay. So the first type of AI agent to note down, these are all types of AI agents, is the model-based reflex agent. Okay. So the model-based reflex agent, in short, it uses its own programmed understanding of something. If I give you a map of something, a map of Disneyland, for example, you're going to be able to use that map to make decisions on which rides to go, which rides, are the most fun. And it doesn't just react to what happens. So like when you go to a theme park, you don't just react to what you see, which ride, because you have a map, and that map allows you to really look through the entire theme park for the best ride. So that's kind of what a model-based reflex agent does. We give it an understanding of the world, and I think this is generally done through, the schemas, the rulebooks that we mentioned before. So it has its own map to say of the world, and it makes decisions. And so that's basically the key thing about model-based reflex agents. It already has something to start with. It's not starting from scratch. So that's model-based reflex agent. And yeah, this will be in the booklet. Remember, as I said before, make as many mistakes as you can on the booklet, because you're going to learn a lot from those mistakes that you make. So don't be afraid of making mistakes. In fact, make a lot. Okay. The second type of agent after the model-based reflex agent, the second type is goal-based agents. Okay, this is pretty simple because the word goal is in in the name. Goal-based agents have a clear mission. They clearly know what they've been created to do or what they're supposed to do, and it finds the best way to succeed. So honestly, any program has a goal. Uh, if you use a calculator has a goal to solve the math problem. But the key thing about goal-based agents, what really makes this an agent, yeah, a worker, is that it's able to adapt when things change. For example, if you give a math problem like 4 times 5, and suddenly the math problem changes to like 4 divided by 5 or something else, the goal-based agent won't have a problem adapting or changing itself to solve that math problem. So just know it can adapt and change. Another type, this is a chess agent. I think this is a pretty cool example, because if any of y'all have played chess before, it's a really, it's a really fun game. And one of the reasons why it's fun is you're playing against an opponent who always makes a different move, who always changes their move. So the chessboard that you see, the the pawns that you see in the previous round are not going to be the same. The arrangement is not going to be the same as that you see in the next round, because at least one, usually one pawn moves. And the goal-based agent has to continuously adapt and change. At the end of the day, the goal of this agent is to win that chess match. So if you've ever played, online chess, and I think I encourage y'all to play online chess because it's really fun. And if you ever play against bots, most of the time, not all the time, but most of the time, a lot of these bots are actually goal-based agents. So they have a goal and they have to adapt to the way you play in order to, win against you. Oh, and also another thing about, so this is a self-driving car. We're going back to model-based reflex agents. I forgot to explain this. But this is a really cool example because self-driving cars have a map of the entire, of the entire city or the entire land area that they're driving around. So using their map, they're able to actually make decisions on how to take you to your destination. So these are cool. This is an example of a model-based reflex agent, a self-driving car. And likewise, a chess agent is an example of a goal-based agent. Yeah. Yeah, I hope I didn't confuse y'all with this. And yeah, so just note that model-based agents, they work on their own understanding, and a goal-based agent has a clear mission. All right. I want to, I kind of want to go forward, but I want to ask y'all, how are you doing so far? We have learning agents over here, and we have one more topic, and then it's just obligate. Does anyone have any questions? Because I know this is one of the more technical sides.
No, we don't.
Okay, cool. Thank you, thank you. Oh, sorry, I think I just stopped sharing. Okay. Oh, you can still see it. Okay, cool. So learning agents, these are basically agents that get smarter over time. They just, observe the environment, try new things out, and they adjust or change their actions based on what works out best. So think of a painter over here. The painting agent has to study, the canvas or what they're drawing on, their drawing board, and it just tries new designs out. And then it adjusts its actions, the designs based on what works out best. So it adjusts the way it draws to ensuring that it's able to, make the prettiest drawing. And in another way, you can see a self-driving car as a learning agent as well, because here's why. The self-driving car observes the other cars, on the road, and it tries different ways to, reach destination. It tries different routes, but it also tries different ways to just stay in its own lane, drive at a certain speed. And at times there's risks that the self-driving car might collide with another car, which is dangerous. So in order to prevent that risk, the self-driving car learns from its behavior and adjusts its actions to ensuring that, the passenger remains safe. That's a learning agent because it learned what would be what is safe driving and what's not safe driving. Another way to learn, I mean, to understand learning agents is to just think about all of us, at school. We're always like observing what the teacher writes on the board or, puts on the screen, and we try to apply it. We try to solve problems, math problems, based on what the teacher tells us. And then if we're not able to solve the math problem, we ask questions, and then we eventually adjust the way we solve the math problem and until we actually are able to find the answer. So that's exactly what a learning agent does. It observes the environment, just like how we observe, what's in the classroom, what's written on the board. And yeah, it's also how, honestly, all of us learn how to do new things. If y'all cook, you would have observed someone else cooking, maybe your parents, maybe your friends, your older sibling, or whoever, and you would have tried your own, cooking style. And sometimes what you make might not taste that good. So you would have tried to adjust the way you cook in order to ensure that it works, in order to ensure that it tastes better. So that's kind of what a learning agent does. Alrighty, so we're on to our final topic. I hope y'all are still sticking with me. Yeah, this is the last one. So after this is the blanket. And this is known as a utility-based agent. So, maybe just take a few moments, stare at this word, utility-based. Many of y'all might have not even heard of the word utility, but basically utility is kind of like happiness. This agent always wants to get the most happiness from whatever it does. It's like choosing between, sweet apples or sweet oranges. Like it has to decide between two good things often. And what it means is sometimes you have to let go of one of them. I'm curious, so in the chat, do y'all prefer oranges or apples? Or let me know. Yeah. So because sometimes you will, sometimes you might have to let go of one. If if you and your sibling have been given one orange and one apple, sometimes y'all could either split the apple and an orange into two, and y'all could have half of each. Or y'all could, split the fruit itself, give one apple to your sibling and keep the orange, or do the other way around. But either way, utility-based agents have to choose between two different paths or two different, good things. An example of a utility agent is a robot vacuum cleaner. I'm not sure if
Mhm.
y'all have seen or even have, these vacuum cleaners that are like robotic or in many cases AI, but oftentimes it has to search for a good path. Sometimes in this case, its happiness, funnily enough, is actually finding the area with the most amount of dust or dirt or whatever. And it has to oftentimes it has to choose between whether to go to your living room, which has who knows how much dust, or whether to go to your bedroom. So it has to choose which path to go to first. And that's basically its utility. It's trying to always maximize the amount of dust it can collect, an AI vacuum cleaner. Okay, so in short, a utility-based agent always wants to maximize its happiness and or utility. And this can come in a variety of different shapes and